USMLE-style question on holoprosencephaly. A newborn is delivered at 38 weeks gestation to a 32-year-old woman with poorly controlled type 2 diabetes. On examination, the infant has microcephaly, cleft lip and palate, and closely spaced eyes, hypotelorism. Brain MRI reveals failure of the forebrain to divide into two hemispheres. Which of the following is the most likely underlying embryologic defect? A. Failure of the caudal neuropore to close during the 4th week of development. B. Failure of the rostral neuropore to close during the 4th week of development. C. Failure of the forebrain, prosencephalon, to divide into two cerebral hemispheres during weeks 3 to 4. D. Defective neural crest cell migration during weeks 4 to 6. E. Disruption of secondary neurulation affecting the caudal cell mass. Answer C. Failure of the forebrain, prosencephalon, to divide into two cerebral hemispheres during weeks 3 to 4. Explanation: this newborn has holoprosencephaly, HPE, a developmental field defect caused by failure of the prosencephalon forebrain to divide into two hemispheres during weeks 3 to 4 of embryogenesis. Pathophysiology: normally the SHH sonic hedgehog signaling pathway regulates forebrain separation. Mutations in SHH, trisomy 13, Patau syndrome, and maternal diabetes increase risk. Severity varies. A lobar HPE, no hemispheric division, single primitive ventricle, severe facial defects, cyclopia, proboscis. Semilobar HP, partial separation of hemispheres, midline facial defects, cleft lip palate, hypotelorism. Lobar HP, nearly complete division with mild facial findings. Strong associations, trisomy 13, Patau syndrome, fetal alcohol syndrome, maternal diabetes. Incorrect options: A. Failure of the caudal neuropore to close during the 4th week causes spina bifida, not forebrain defects. B. Failure of the rostral neuropore to close during the 4th week leads to anencephaly, not holoprosencephaly. D. Defective neural crest cell migration during weeks 4 to 6, associated with neurocrestopathies, e.g. DeGeorge syndrome, Hirschsprung disease. E. Disruption of secondary neurulation affecting the caudal cell mass, linked to tethered cord syndrome, not forebrain malformations. This question tests embryologic development of the forebrain, specifically holoprosencephaly and SHH signaling defects.